Hello everyone. Today I am going to simulate the projectile versus RCC panel in Abaqus Explicit software, where the projectile hits an RCC panel. The base of this simulation is I am using the research paper Impact Journal of Impact, International Journal of Impact Engineering. This is the hard projectile performance on the monolithic and segmented RCC panel with ray steel liner. I am using the projectile of this shape having this dimension. I give this in description, PDF link in description. The weight of the projectile, mass of the projectile is 386 gram, and they done this experimental work for 100 mm, 150 mm and 200 mm panel thickness of size 675 by 675 mm. The reinforcement in the panel is the diameter bar is 6 mm. They provided the detailed link of the reinforcement also. Okay, uh, let's start modeling on Abaqus. Okay. Initially, set work dictionary. Trial for 150 mm thick RCC panel. Okay, then create a part, projectile, considering an analytical rigid. The base feature revolved shell, and as per the paper, the minimum size is 25.3 mm. I'm considering everything in meter, so 0.5. Okay, line, take line, draw, second point, then e power minus 3, enter, 110 e power minus 3, enter, then for head, I select the arc, draw, measure it, 42 e power minus 3, enter, done. Coming to the properties, tools, create on reference point, tools, reference point, select the point, okay, then assign some mass because we consider this projectile as the analytical rigid. So the weight of the projectile is given in the paper 386 gram, 0.386 kg. Okay, then special inertia, create heat capacitance, select the reference point, done, provide it as 450. Okay, then coming to part, create new part, RCC target of 150 mm thick. I consider this as deformable solid. Solid extrusion I am using. For size, it's 675. The funnel size is 675 by 675. So 0.675 I am considering as it is. Rectangle to rectangle. 0.675 enter. 0.675 enter. Done. The thickness of the plate is 0.15, 150 mm, so 0.15 meter. Okay. Then properties. I have my predefined library where I am using the for concrete aluminum modified to concrete. So I'm importing that. Save changes. Dismiss. For RCC panel, I'm using the Johnson Holoquist model because uh, in Abaqus there is no dedicated UMIT program. So I'm using the modified version of Johnson model. In that, density has concrete mass density is 2400 and elasticity is 34 GPa. Then expansion plasticity. I'm selecting Johnson Cook in this. For high velocity, the RCC panel behave like a brittle material rather than a plastic. It shows a brittle nature. For steel, I am using density 7850, elasticity 2 GPa, 2.1 GPa, plastic stress and plane strains. I am considering the steel as isotropic. Okay. Create this section. RCC target. A solid section. Continue. Material is okay. Create another material for reinforced rebar of 6 mm dia. I am considering the bar has the truss element. I am mentioning the area of the rebar. Continue. Select steel. Okay. Then assign these sections. Select the reinforced panel. RCC panel. Done. RCC target. Okay. Coming to the okay. I need to model the rebar also. For rebar, go to part again. Then create a part. Rebar 6 mm dia. Deformable wire planar. Continue. The length of the rebar is 125 625 mm, that is 0.625 625 enter. Done. Now property, assign section, select the rebar. Done. The rebar of 6 mm dia. Okay. I just forgot to mention the area, cross section area of the rebar. The area of the rebar is 3.14 into 6 into 6 divided by 4. It's come around 28.26. That is 2.826 e power minus 5 meter square. Okay, dismiss. Then I'm going to step module, create a step, initial, dynamic temperature displacement explicit. The time I'm considering 0.001 second. This is depending upon your simulation time. Okay. Now coming to part again, select the target. I need to create a impact zone. I need to assign the impact zone as finer mesh as given in the paper. In paper 3, that is depends on. Basically in this paper, they use this based on the simulation for comparison of low and high velocity projectile loading. They consider for low velocity the TDP model, for high velocity Johnson-Holmquist model, where they consider the impact part. They provided the finer mesh of 5 mm, 5 mm by 5 mm, 5 mm. Other part 20 mm by 20 mm. So I am doing the same thing. Tools, partition, face, sketch. Select the face. Done. Select the edge. Done. Take a rectangle. 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3. This is exactly at the center. Just show you. 0.22. Enter. 0.22. So it's in the center. Enter. Cross. Done. Now do extrude. Extrude or sweep edges. Select the edges. Hold the shift button and select the multiple lines. Done. Sweep along the direction. The direction is fine. Okay. Create partition. To see the partition, create on wireframe. Then select the cell partition. Done. Okay. Now we need to mesh the go for mesh. Create mesh. The approximate global size is 20 mm. 20 e power minus 3. Apply. Okay. For seeding, for impact zone, they provided the final mesh. Select the edges, holding shift. Done. Provide approximate size has 5 mm, 5 e power minus 3. Apply. Okay. Done. The numbers 25, apply, or make it as 20, apply, that's 15. No, we made it as 26 only. Apply. Okay. Now assign element type. Select the element. Done. Explicit 3D stress continuum, 3D stress hexagonal, reduced integration, C3D8R for concrete. Okay, done. Before meshing, I need to do assembly. Go to assembly, create instance, select import the all, apply. Okay. Rotate instance, select the projectile, done. Select the axis of rotation, 90°, done. Okay. Select the projectile, done. Initial point, move instance, select the instance. Okay. First point, second point. Okay. Again, select the instance, done. First point, second point. Okay. Again, select the instance, done. Select the axis. Okay. Provide 30 mm EPROM distance. Okay. Done. Now I need to adjust the reinforcement. For that, I am removing the projectile, hiding the projectile, remove. Okay. Then select the bar, done. Select the midpoint of the bar. Okay. Second bar, done. Done. Now I need to provide the cover has 25 mm. So I need to initially hide the target, select instance, done. Add, select the axis, provide 25 mm e power minus 3. Okay, done. Now, then linear pattern, select rebar, done. Since the length 75 mm, reverse 25 e power minus 3. Okay, okay, one more. Okay, now remove the selected cell. Done, done, done. Uh, for moving the instance, select done, add projectile RCC target, then select the axis, click 25 mm, e power minus 3, continue. Done. Again, remove the target, then pattern, select, done. Okay, rotate the target. Okay, select the target, then turn on this axis, turn, make it as properly. Okay, select this, move the instance, select, select the instance, turn, select, remove midpoint of the projectile, sorry, remove, and second part point as perfect. Done, done. Now remove the target, remove, delete the external bus. For that, click on erase, click, shift, click, 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 done. Okay, delete the selected features and all children. Yes, done. Now import the target, add. Okay. Before importing, we need to place the bar one above the other For that, move, select instance, done, and okay, select the direction, okay, flip it. The thickness of the rebar is 6 mm, e power minus 3. Okay, okay, done. Now again, remove the target, select instance, done, add the target. I need to change the 150 mm, it's become 1500, and this, flip it. As per our paper, we need to provide 18 mm from the face. So provide 18 mm, e power minus 3. Continue. See it slightly. Okay. Okay. Again, remove the target. Select the reverse. Create a pattern. Select rebar. Done. And okay. Select the direction. Okay. Make it as 57 mm. 57 e power minus 3. Okay. Increase it to 3. See by side view. Okay. Looking good. Okay. Now view in 3D. Okay. For further increasing, go to graphics option, rendered profile view. Okay. This view may visible to you quite good. Okay. Coming to the view again on material. Now mesh part. Select the part rebar. Okay. For rebar also provide fine meshing. Then size. The 5 mm is the finer size of line. Now there are many rebar. To minimize the computation time, increase this it to 15 mm to power minus 3. Apply. Okay. Done. Now prepare mesh S. Okay. Meshing is good, but I need to increase the for this. So I will do seeding again. Seeding. Remove Okay. Select the edges. Then decrease this to 15. Apply. Delete. Apply. Okay. Now to mesh S. Now quite good. Okay, no problem. Then go for loading. Loading. Create boundary condition. Step 1. Mechanical. Displacement rotation. Continue. Select the region. Select the bottom and top of the plate. Okay. Shift. In 3D. Quite good. Okay. Restrain in all the direction. Okay. Then create boundary condition 2 for initial step. Displacement rotation. Okay. Now select the reference point of the projectile, turn, and tick all except U3. U3 is the Z direction. Then create predefined field, like field 1, initial, the temperature. Select the RCC target only. For that, you need to hide all 5, selecting them, remove, make sure. Okay. Now select the target. Okay. Provide the temperature is 27 degrees Celsius. It's the room temperature. Okay. Now revolve. Redefine field 2. For that, initial mechanical velocity. Select the reference point of the projectile. Okay. Provide velocity. In the paper, they given the velocity of 540. For in the experimental work, they provided initial velocity, striking velocity is the projectile is 536. So I'm going with it minus 536. Okay, the direction is the right direction. Then it's okay. Then go to interaction, create interaction property, initial, general contact, create interaction property, contact. Okay, tangential, penalty. Provide the friction has 0.02. Okay, then Go to Tools, Surfaces, Create, name it as Projectile. Okay. Select the body, done. The surface is brown. Okay. Then again, go to Tools, Set, Create. For this, we target. Select the noded region. Continue. For that, done. Select the nodes, done. Then create interaction, initial, surface to surface. This is the surface to surface interaction between the projectile and the RCC panel. So in first surface, select the projectile, highlight it, continue. Then the noded region. For that, you just created the node target. Continue. Keep this as it is. Okay. Okay. Now I need to create the embedded region also. So create interaction. Sorry. Create constraints. For constraints, type embedded region, steel bar and concrete. There is for RCC. Click embedded region. Continue. Select embedded region. For that, I need to remove the RCC target and projectile. Remove it. Wait a minute. What is highlighting here? Okay. Now select the reinforcement. Done. Select the host region. For that, insert the target and add to select the region, host region. And remove the reverse. It might be more easier. Okay. Or I'll select this. Done. Keep this as it is. Okay. Now the concrete RCC reinforcement is created. The embedded region is created. You just see these circles. It indicates the contact between the reinforced concrete and the steel. Now click on step. Here we need to create the set for reference. Step tools reference. No, sorry. Uh, tools, set, create a set, then select the projectile reference point, name it as RP, continue, okay, done. Then click on history output, step 1, continue, domain, set, here the reference point. Here we need to select the velocity, that is in direction of V3. For the projectile, we are only considering the velocity. Okay. Then field output manager, edit. Here we need to increase, we need to add the failure measure components and damage initiation criteria. And in the state, we need to add status of failure plasticity model, that is UMAT. Okay, I'm making the interval as 10 to reduce my computational time for the whole model. Okay, then go for job. Here, create job. I'm giving the title of the speed is 536, 536 meter second, meter second for for RCC of 150 mm thick. Continue full analysis and use multiple processors. I'm using 8 precision single. Okay, submit. Okay, the rebars are not missed. No, hold a second. Then go to mesh part, rebar, mesh them. Okay, yes, now they are meshed. Chop, submit. The file is submitted. You may also check the status. You can also check the error and warning output data and status. If the status file is generated, then the model is started running. You can also check for warnings. This is my first warning. Let's wait. The solution is in progress for this step. You can see the mass scaling factor 0 increment is 1 and they are creating the output database file was 0 out of 10 requested. So it took around 2 minutes for one step. It's completely depending upon your mesh size and your You may also increase the domains in parallelization. You may increase this to 16 to reduce this weight with the last domain. It may also increase your execution time.